Welcome to Vision Plus and welcome back to this senior for mathematics and complex numbers. We are now looking at argument of a complex number. And by definition, we are saying that the argument of a complex number z is defined to be the angle. This is very important. It's defined to be the angle which the complex number makes with the positive x-axis. So it is an angle which is made or measured from the positive x-axis. Let me explain these terms. If you are given a complex number z as x plus iy, what is the argument of z, which we are calling arc z? What would be the argument of this complex number z? Now, the argument, we are saying that it is an angle. So, whenever you are getting the argument, you must get for us an angle, either in degrees or in radians. For instance, let me represent this on the Argand diagram and we see how we can get the argument. Remember, for you to get the argument correctly, you must first illustrate that complex number on the Argand diagram. So let me draw the Argand diagram, which has two axes. This is the real axis. This is the imaginary axis. This forms the complex plane axis. This is the origin that you can mark. Now, x is the real part because it is not containing I, but y is on the imaginary axis because it is containing I. So, assuming my x is somewhere here and my y is somewhere here, let us look for the point of intersection of x and y. Horizontally straight and vertically straight. They are meeting somewhere there. Then you get your ruler and then you draw a straight line from the origin up to that point of intersection, like that. And then you put an arrow on top. Okay, this is our complex number z that we have drawn here. Now, where is the argument? The argument is the angle which we are going to measure from the positive x-axis. Remember, real axis is x-axis from the Cartesian plane, but we changed it to the real axis. So this is the positive part of x. This is the positive from here up to there. This is positive part of x. And then beyond 0 here, this is the negative part of x. This is the positive part of x. So we are measuring the argument from the positive x-axis, which is here. That means this is the positive x-axis. Now the argument is this angle that the complex number will make with the positive x-axis. In other words, it is the angle of inclination of the complex number to the x-axis. So this is what we are calling the argument, theta. That symbol is called theta. The symbol is called theta. So this angle that the complex number makes strictly with the positive x-axis is what we are calling the argument. Even if the complex number was in this format, we just assume I may not put here values. This is the real axis. This is the imaginary axis. Even if the complex number was pointing in this direction, remember we look at very many examples. Even if it is in that format, this is the complex number, maybe z. Now, what is the argument? Still, the argument is the angle that we shall measure from the positive x-axis. This one becomes the argument. It doesn't matter where the complex number is pointing. What if it is in this format? What if it is in this format? What if the complex number is here? Something of that sort. Assuming you draw a complex number and you obtain something like that. This is Z. This is the real axis, which is the real part of Z. This is the imaginary part of Z. What is going to be the argument in this case? This is Z. The argument in this case is the angle that we are going to measure from the positive x-axis, which is from here all the way up to here. This is the argument theta. Okay. Now, what do you need to take? Remember, if you are taking an angle and you are moving anti-clockwise, it is positive angle. Anti-clockwise, that angle is positive. I'm saying positive angle. You get positive angles. But if you are moving clockwise, here you are taking negative angles. And we shall see that when we are doing numbers. Now, I need to tell you that I've already said angles are measured in two formats so far at this level, in degrees and in radian. This is just introduction and overview. Units of measurement of angles. One, you can measure angles in degrees. Two, you can measure angles in radians. The one for degrees is where you see this here, and the one for radian will be saying sort of pi. Be saying pi. Now, what is the relationship between the two units of measurement? Remember, a complete revolution. For instance, a pie chart. A complete revolution. This revolution here is 360 degrees. Because here is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. So one complete revolution is equivalent to 360 degrees. Also, it is equivalent to 2 pi. That means that if one complete revolution is 360 degrees and still one complete revolution is 2 pi, what is now the relationship between degree and radian? This implies that, let me put it here, NB. Therefore, 360 degrees is the same as 2 pi. Or you can just say 2 pi is the same as 360 degrees. The two sides are equal. What does it mean? You can simplify by dividing both sides by 2, so that you get that the value of pi is the same as 180 degrees. So pi is the same as 180 degrees, which is half of the revolution. That means you are moving from here and then you stop here. You have not exceeded half of the revolution. So this is what you must always keep in your mind, that the complete revolution is 360 degrees and it is also 2 pi. That implies that 2 pi is equal to 360 degrees. So this is what I thought is important for us to look at in the introduction.